Today I'm going to talk about the GRF 2070 and the 2080 families of LNAs. The 2070 and the 2080 families of LNAs are both super low noise, probably the lowest noise figure LNA I've seen. Both of them are DFN8, meaning they're 8-pin. The main difference would be the 2070 uses a V-enable pin, which allows you to control the bias current. The 2080 does not. The 2080, we substitute out the V-enable pin for a shutdown pin. So for applications where a quick turn-off time of about 1 microsecond is needed, our 2080 can satisfy that requirement. Whereas turn-off time isn't as important. The 2070 has a slower, about a 10 times slower turn-off time, but the difference is you can control the bias current through the source using our external bias resistors. Where the parts are most similar is their noise figure, extremely low noise figure, and their current range. They're both able to be tuned down to probably about 10 megahertz up to about a gig. They're both basically the same die internally, just with one with shutdown, one without shutdown. So they're both tuned for the same frequency range. And when we talk about ultra low noise figure, the noise figures are reaching the limitations of the equipment that we measure the noise figure with. So I see noise figure measurements in our screen room of between 0.16 and 0.18 typically on the 2080 and the 2070, which almost seems not realistic. So a lot of times when we report the data to customers, I typically round up to like 0.25 or 0.3 so that it seems more realistic. And additionally, if anybody samples our 2070 and 2080, I'd love for them to share what kind of noise figures they read in their labs. It'd be great to correlate these numbers. So the 2080, the turn on time and turn off time are the same. They're both 100 nanoseconds. The 2070 is slower because it doesn't have the shutdown pin. Its turn on time is 1800 nanoseconds. The turn off time is around 900 nanoseconds. So the 2070X and 2080X family, there's a whole family of parts that represent the 2070 and 2080, and we designate them 1 through 4. So we have 2080, 2081, 2082, 23, 2084, and the same with the 2070. What we do is we offer you different frequency ranges. So the higher the number for the last digit, the higher frequency the part will get you. So 2070, for example, is rated between 100. Sorry, what is it? Its lowest frequency offering is between 100 megahertz to about 1.5, 1.7 gig, and then whereas the 2071 would then be probably around 1.8 to 2.5 gigahertz and on upwards. And the same with the 2080. So if your application requires a gain peak at a certain frequency, then you base that off of which part you're going to select. The 2080X family has the same turn on and turn off time as you go up in frequency with the different family offerings. They're all around 100 nanoseconds on, 100 nanoseconds off. Whereas the 2070X family, as you go up in frequency with the 2070 1, 2, 3, and 4, the turn on times do improve, and the turn on and turn off times do improve, but they're still not as fast as the 2080X family is going to get you. For IP3, the typical output IP3 is around 36 to 38 dBm for this family of parts. And interestingly, the output P1dB is about 3 dB lower on the 2080 than the 2070. The 2080 P1dB is around 17. For the 2070 family of parts, the P1dB is around 20 dBm. And I'm not really sure why. Could be the circuitry involved for the shutdown, but something's limiting the power capability. But as far as the data sheet goes and data I've seen, the IP3s are around the same. Both parts, both families will operate at the same voltage ranges. The difference is, once again, the 2070 family, we break out the source through a V-enable pin, meaning that you can, at any voltage where the part is, you can operate the part. You can change, you can control the current by increasing or decreasing the bias resistor that's on the V-enable pin. The 2080 does not have that feature, so you can only adjust the voltage through the drain on our VDD line, and you can't modify the current consumption. So that would be a negative for the 2080. Both of these families of parts, are both Cascode. They operate from about 2.5 volts up to 6 volts. Typical bias current is around 70 milliamps. But like most of our products here at Guerrilla RF, they're very customizable, and we can lower and raise currents, lower and raise voltages based off of customer needs. Our parts are very versatile, and we have many custom tunes for lots of different customers throughout the years. The main issues I've found with these parts is the amount of gain roll-off or lack of gain flatness seems to be a turnoff for some customers. Ideally, if there was some sort of feedback circuit internally, we could have a flatter gain response, but the trade-off would be probably worse noise figure and probably worse linearity. So we choose to promote the best possible noise figure, and so also the best linearity or IP3 that we can provide. We prioritize that over gain flatness with these families of parts. They're very easy to tune. They just have a simple DC blocking cap on the input and a DC blocking cap on the output. The cool thing is you can put a big, like, huge inductor on the choke. It'll allow you to tune the parts down to like 10 megahertz. You will have a bump in your noise figure there because your S11 return loss will be really sharp. It'll have a really sharp edge right at the lowest frequency possible for this part, which is around 10 megahertz. So that kind of tune, like a 10 meg to 500 megahertz tune, you'll have maybe 2 dB noise figure right at 10 megahertz, but it'll exponentially improve back down to its typical 0.5 dB or better range within a few megahertz of that point. So huge choke inductor on the output for the 2080 family and the 2070 family, and we can get your frequency response extremely low. So I think over temperature they're really stable. I haven't seen any instabilities that stick out. Gain, IP3, P1dB, and noise figure both degrade or slightly improve uniformly across the whole family of products. The one thing that's good about these parts is the package that they're put in is the DFN8 package, which allows for a larger ground flag, better thermal escape. They're more stable because they have a better connection to to the ground that's typically underneath our package on whatever the PCB is that the customer is using. Typically, we see those kind of stability problems when we put these die in our DFN6 packages, but we accommodate for that with other external tuning hooks that we know about to keep the part stable. But in the DFN8 package, the products rarely, if ever, have a stability issue, especially the ones that are lower in gain, such as the 2070 and the 2080X parts, which are 20 dB or lower of gain. I would say common customer applications would be anything you want right after the antenna. If you want to have the advantage of a super low noise figure, such as 0.3 dB or probably lower, you're creating a receive environment where the faintest signal that you're trying to receive isn't being drowned out by the noise. So your noise floor is extremely low, allowing for you to receive the signal that you're wanting to receive. One thing that's really common with these products is when people want a higher gain solution, when we have to sometimes cascade our LNAs together or have an LNA paired up with one of our gain blocks, the 2080 or the 2070 will be our go-to for a first stage, typically followed by maybe a 2105 or another higher noise figure, flatter gain solution. That way the customer gets a cascaded 2-stage or sometimes 3-stage LNA solution that still maintains a really great, probably below 0.5 or 0.4 dB noise figure, and maybe 30, some custom tunes we've done up to 50 dB of gain, where we just cascade multiple gain blocks after a 2080 or a 2070. The 2080 could be preferred because with that shutdown pin, if something comes through the receive chain that you're not wanting, you can instantly snap a digital signal and you could use the shutdown on the 2080. And that typically provides a 30 dB, negative 30 dB attenuation to whatever's coming in through the input. So it's a good way to protect your receive chain with the 2080 because you can snap it off within 100 nanoseconds and instantly attenuate any unwanted signal.
Thank you so much for watching. If you'd like more information, please email us at sales@guerrilla-rf.com. And don't forget to subscribe to our channel for more content from Guerrilla RF.